Hello, how you doing? It's Mr. Do the Math here. Today we're talking about annuities, particularly IRAs and different kinds of savings, right? And so we're in chapter 8. And chapter 8, those variables that we used last chapter are the same. P represents what P represented last time. What's P? P is the principal. And the principal is usually like a deposit. Right? T represents what? Time, which is always in years. R is rate, which is always in a decimal. And then N represents what? Number of payments, right? Number of payments per year, right? So, today we're just gonna talk about like calculating like an annuity, the annuity amount, and we're gonna look at the interest as well. Okay? So here's our first situation. Okay? So we have a 35-year-old. Got a 35-year-old, right? They decide they want to save for retirement by depositing $1,000 a year, right, for 30 years at an interest rate of 10% a year. All right. How much will they have in their IRA after 30 years? Okay. This is the formula that we will use. All right. We didn't talk about it. A equals. It's a bit long. P times the quantity of 1 plus the rate to the T power minus 1 all over the rate. Okay? So, P is 1,000, right? Times 1 plus the rate, which is 0.10 to the 30th power minus 1 all over the rate again. Okay? So because this equation is so long, you could put this all in the calculator at one time, but you need a lot of parentheses, right? Or you can just break it out. You can break it down and work it out like we do PEMDAS. All right, so the first thing we got is this 1 plus 1.0, which is 1.0 to the 30th power. So you got 1,000 on the outside. 1.0 to the 30th power minus 1, right? All over 0.10. All right, so 1.0, I need a calculator. 1.0 to the 30th power is what? 17.4. 17.4. So let's break it all down. 1,000, 17.4 minus 1 over 0.10 gives you 1,000 times, so that's 16.4 over 0.1, right? Multiply this through 1,000 times 16.4, you're gonna get, instead of 64. So that means that this is a decimal. It's more numbers.
Oh
yeah, it's more numbers. So we'll talk about that in a second. So that's 6,4,0,0, 1, 2, 3, 1, 2, 1, 2, 3, right? Over 0.10. Divide that, and what do you get? $164,000. Right? Now, this is if this was really 17.4. All right? So what you have to make sure that you do is we don't what's the word? We don't round, right? We don't round too soon. So once you get here, 1.1 to the 30th power, leave that number there, right? So whatever that number is, with all its decimals, just push minus 1, which is going to give you 16.4 and some change. It keeps going on and on and on. And then multiply it by 1,000. That's going to give you 16,400 and something. And then divide that by 0.10. Like, don't round. Do not round until the end, because the answer should have been like 164,494.
Yeah.
Point, huh? So that's rounded to the nearest whole number, right? So some students got this. We got this?
Yeah, I got this.
All right, cool. Any questions about that so far? No? Okay. Let's try another one. All right, let's try another one. Same thing. All right. So what if we got, oh yeah, this is another part. Here we go. So this is how much the IRA is after retirement, like in 30 years. So 65. Retirement age is 65. So at 65, they would have $164,494 in their account waiting for them, right, to go into retirement. That's a lot, but it's not a lot, because like technically when you retire, that means you ain't working no more. So you're just living off of this money until you die, right? So you need more money, all right? But here we go. So we got this amount. The next question is, how much interest did they gain over the 30 years, right? So let's look at the interest, right? So to calculate the interest, you got to look at two things. You got to look at the amount you made, and then you got to look at how much you paid. So you will look at your principal times time, which represents like, all right, they paid $1,000 30 times. All right. So how you doing? I like that time, man. Good. Thank you.
Is that student here?
No, he's not. This is the second person.
We were asking where did that student go?
I don't know. I think we're home. Yeah, he never came here. Thank you. Thank you. All right. So like we got 164,494, right? Minus P times 2, which is 1,000 times 30. Right? And you subtract that. That's 30 is like 30,000. So how much interest did they make? Calculators. Where's my calculators at? What we got?
134,494.
Right. That's how much they made in interest, right? So to calculate your interest, you use this formula here. A minus P times T. P being the principal. Okay? Cool. All right. Now, what if, so this is the case if you make one payment a year into your savings, right? One payment a year. Now, let's look at the different number of payments a year, okay? Then we'll be done. So this is for one payment a year, right? So for multiple payments a year, you'll use this formula, right? A equals P times the quantity of 1 plus R over N to the NT power, right? Minus 1 all over R to the N, okay? That kind of looks familiar like last chapter, right? This part, okay? So, let's set up our scenario. Here we go. So, at 25, you save for retirement. You decide to deposit $200, all right? You decide to deposit $200 at the end of each month, all right? Monthly means how many? 12, right? Into an IRA that pays 7.5%, right? Compounded monthly, all right? How much will you have from your IRA when you retire at 65? So if you're 25, at 65, how many years have passed? 40 years, okay? So we're gonna take all of this information and we're gonna use this formula. Whenever they tell you a certain number of payments that they're making a year, we gotta use this compounded formula here, okay? So let's plug everything in. So we got 200 times the quantity of 1 plus the rate, 0.075. Make sure you put, make sure when you change this decimal, you're paying attention. When you change it to a decimal, you're paying attention to where your decimal is. Over number of payments raised to the 40 times 12, right? All minus 1. All minus 1 over 0.075 over 12, right? So again, it might be best to follow other operations to figure this out. I need somebody to calculate for me. All right, so we're gonna do parentheses first. It's 1 plus 0.075 over 12. So let's put the 200 on the outside. All right, so it's gonna be, what's this? 1 plus 0.075 over 12. Where we at?
1.00625.
0.00625 raised to the, what's that? 480 power. All right, so here we go. So this raised to that minus 1. So it's 200. And then we got, what's the answer from the last one raised to the 480?
Minus 1.
Yeah.
18.89888859.
Okay. All right, so multiply that into 200.
Oh. 3,779.77718.
Okay. All right, divide that by 0.075 over 12. So put that in parentheses. So divided by parentheses this. You should get Did you get 604?
Yeah.
604,765.
Yeah. Okay.
Right. 764 in point what?
4348.
Okay. Well, look, it's for 40 years though. You deposit in $200. Well, you deposit in $200 12 times for 40 years. So I better have some money in that, right? Right. So now, that's how much is in their IRA. How much interest did they incur? So like, let's calculate the interest again. All right. So the interest is gonna be, we'll put it right here. Interest is gonna be the amount 604. So 765 minus 200. This time you gotta multiply. It's gonna be P times NT, right? Because you made this payment 12 times 40. Okay, so PNT. So there's gonna be 200 times 40 times 12, or 12 times 40. All right. Okay. What did you guys get? She get 508,000. 508,000 what? 764. All right. Any questions? Does everybody understand why we use P and T in this problem versus PT in that problem? Huh? Any? Exactly. You're making multiple payments a year versus making one payment a year, right? So that's what's going on here. All right. So this is pretty much the lesson for today, right? So calculating what your annuity or your IRA would be if you make one payment a year, and calculating what your IRA value or your savings account would be if you made multiple payments a year, right, for a specific period of time. Okay? So, if you have any more questions, comment below. Don't forget to like and subscribe. This is Do the Math out.